100 facts about surds. Surds are irrational numbers that cannot be expressed as a simple fraction. They often involve square roots or higher roots of non-perfect squares. Here are 100 facts about surds. Basic properties. 1. Irrationality. Surds are irrational numbers, meaning their decimal representation goes on forever without repeating. 2. Non-perfect squares. They involve roots of non-perfect squares. 3. Simplest form. Surds are usually expressed in their simplest form, meaning no perfect square factors remain under the radical. 4. Multiplication. Multiplying surds involves multiplying the numbers under the radicals and placing the result under a single radical. 5. Division. Dividing surds involves dividing the numbers under the radicals and placing the result under a single radical. 6. Addition and subtraction. Surds can only be added or subtracted if they have the same radicand. 7. Rationalizing denominators. To rationalize a denominator containing a surd, multiply both the numerator and denominator by the conjugate of the denominator. 8. Conjugate. The conjugate of a binomial containing a surd is obtained by changing the sign between the terms. 9. Surd equations. Equations involving surds can be solved by isolating the surd term and squaring both sides. Specific surds. 10. Square root of 2. Square root 2 is a common surd and its decimal representation is approximately 1.41421356. 11. Square root of 3. Square root 3 is another common surd and its decimal representation is approximately 1.73205081. 12. Golden ratio. The golden ratio, represented by the Greek letter phi, is a mathematical constant that involves the square root of 5. 13. Cubic roots. Cubic roots, such as 27, are also surds when the radicand is not a perfect cube. 14. Higher roots. Surds can involve roots of any degree, such as 16. Surds in geometry. 15. Pythagorean theorem. The Pythagorean theorem involves surds when dealing with non-right triangles. 16. Trigonometric ratios. Trigonometric ratios, such as sine, cosine, and tangent, can involve surds when dealing with non-special angles. 17. Geometric mean. The geometric mean of two numbers involves a surd. 18. Regular polygons. The side lengths of regular polygons with more than 6 sides often involve surds. Surds in algebra. 19. Quadratic formula. The quadratic formula can involve surds when the discriminant is negative. 20. Simplifying expressions. Surds can be used to simplify algebraic expressions. 21. Solving equations. Surds can be used to solve equations involving radicals. 22. Inequalities. Surds can be used to solve inequalities involving radicals. Applications of surds. 23. Physics. Surds are used in various physics formulas, such as those involving velocity, acceleration, and energy. 24. Engineering. Surds are used in engineering calculations, such as those involving structural design and fluid dynamics. 25. Architecture. Surds are used in architectural design, such as in calculating the dimensions of buildings and structures. 26. Art and design. Surds can be used in art and design to create patterns and structures with unique properties. 27. Mathematics. Surds are fundamental to various areas of mathematics, including algebra, geometry, and number theory. Surds in nature. 28. Golden ratio in nature. The golden ratio appears in various natural phenomena, such as the arrangement of leaves on a plant and the spiral patterns of seashells. 29. Fractals. Fractals, which are self-similar geometric shapes, often involve surds in their mathematical description. Surds and number theory. 30. Irrational numbers. Surds are a subset of irrational numbers. 31. Transcendental numbers. Some surds, such as square root pi, are transcendental numbers, meaning they cannot be expressed as the root of a polynomial equation with rational coefficients. 32. Diophantine equations. Surds can appear in Diophantine equations, which are equations where the solutions must be integers. Surds in calculus. 33. Limits. Surds can appear in limits involving functions that are not defined at certain points. 34. Derivatives. The derivatives of functions involving surds can be calculated using the chain rule. 35. Integrals. The integrals of functions involving surds can be calculated using various integration techniques. Surds and probability. 36. Normal distribution. The standard deviation of a normal distribution is often expressed as a surd. 37. Confidence intervals. Confidence intervals for statistical parameters can involve surds. Surds and computer science. 38. Random number generation. Surds can be used in algorithms for generating random numbers. 39. Cryptography. Surds can be used in cryptographic algorithms to provide security. Surds in games. 40. Video games. Surds can be used in video games to create realistic physics simulations and to generate random numbers. 41. Board games. Some board games, such as Monopoly, involve the use of dice, which can generate random numbers that are expressed as surds. Surds in music. 42. Musical scales. The frequencies of notes in certain musical scales, such as the Pythagorean scale, involve surds. Surds and astronomy. 43. Orbital calculations. Surds can be used in calculations involving the orbits of celestial bodies. Surds and medicine. 44. Medical imaging. Surds can be used in medical imaging techniques, such as MRI and CT scans. Surds and economics. 45. Financial modeling. Surds can be used in financial modeling, such as in calculating the present value of future cash flows. Surds and linguistics. 46. Phonetics. Surds can be used in the study of phonetics to describe the sounds of languages. Surds and psychology. 47. Cognitive psychology. Surds can be used in cognitive psychology to study how people process information. Surds and sociology. 48. Social networks. Surds can be used to analyze social networks and identify patterns of relationships. Surds and political science. 49. Voting systems. Surds can be used to analyze voting systems and assess their fairness. Surds and environmental science. 50. Ecological modeling. Surds can be used in ecological modeling to study the interactions between organisms and their environment. Surds and history. 51. Ancient civilizations. Surds were known and used by ancient civilizations, such as the Babylonians and Egyptians. 52. Greek mathematics. Surds played a significant role in the development of Greek mathematics, particularly in the work of Pythagoras and Euclid. Surds and philosophy. 53. Philosophy of mathematics. Surds have been a topic of discussion in the philosophy of mathematics, with some philosophers arguing that they are inherently irrational and cannot be fully understood by human reason. Surds and religion. 54. Sacred geometry. Surds are often used in sacred geometry, which is the study of the geometric forms found in religious and spiritual traditions. Surds and literature. 55. Poetry. Surds can be used in poetry to create a sense of mystery and intrigue. 56. Prose. Surds can be used in prose to describe complex or abstract concepts. Surds and art. 57. Visual art. Surds can be used in visual art to create patterns and designs with unique properties. 58. Sculpture. Surds can be used in sculpture to create forms with unusual proportions. Surds and architecture. 59. Building design. Surds can be used in building design to create structures with unique shapes and proportions. 60. Urban planning. Surds can be used in urban planning to design cities and neighborhoods with efficient layouts. Surds and engineering. 61. Civil engineering. Surds are used in civil engineering to calculate the strength and stability of structures. 62. Mechanical engineering. Surds are used in mechanical engineering to design and analyze machines. 63. Electrical engineering.